Welcome to everybody who has joined. We're still waiting for several more people. Thank you for joining our webinar about media and 5G. We're really happy to have our three speakers here today. Ian Wagdin from the BBC, Jurgen De Klerck from Proximus, and Jens Buysse from Citymesh. My name is Sarah Markwich, and I am representing Howest University of Applied Sciences. We are one of the partners in the Living Lab Media and 5G project, along with API, University of Applied Sciences. My colleague Yasmin from API is there, and my other colleague Tom from our Howest 5G lab is with us as well. Feel free to use the Q&A section to add any questions that you come up with during the presentations. And at the end, we will try our best to answer some of those questions. What we don't get to, we will send you a follow-up email with, and we will also send a recording of the presentation because many people requested that. So I'm immediately going to pass the mic over to our keynote speaker, which is Ian from the BBC, and he can introduce himself a little bit more and we'll get going. Again, thanks for joining. Enjoy. I hope you learn a lot. And if you have any questions after or during Q&A, technical problems, contact my colleague Tom De Kabela. You've received his email address in the email I sent this morning, and enjoy the webinar. May I ask my colleagues to turn off their cameras other than Ian? And Ian, the floor is yours.
Thank you, Sarah, and thanks for inviting me today. I'm just going to start showing my screen so that you can see what I'm talking about. Hopefully, if I do that, and that you can see the screen. So firstly, hi, my name's Ian Wagdin. As Sarah said, I work for the BBC in research and development, and I've been looking at 5G both with the BBC but also the Broadcasting Union, the EBU, for about 5 years now, starting with the standards, so working with 3GPP on some of the standards and some of the sort of prep work about what our requirements were, what we might need networks to do, and then latterly more in sort of practical deployments and stuff like that. So I'm going to sort of talk through a little bit of an introduction. Firstly, I'm going to define what I mean by production and contribution. Then we'll talk a little bit about some of the architectures we've used, particularly standalone non-public networks, and then some practical examples, and then I'll touch a little bit on network slicing. So firstly, I'll talk a little bit about what we do in media for those of you who aren't familiar with it. So I've divided it really into these two scenarios. The first one is contribution, which is primarily used for news gathering, and we use a lot of mobile technologies these days for getting stories back from the field. Quite often you've got a camera, a reporter with a backpack from a company like Mobile Viewpoint or Live View or similar. Those bond several SIM cards together, and then we send that back into the studio for live contribution. And then the production use case is where we currently use a lot of wireless technologies that are digital technologies, really, rather than IP-based technologies. Quite often these are multiple cameras, lots of devices simultaneously. They're in a very sort of planned, confined area. If you think about a steady cam at a football match or something like that, that's the sort of thing that we would use them for. But these tend to have to be very high quality, very low latency, and quite often we need things like time synchronization and stuff like that. So there's a lot of new opportunities in that area, and it's that we're doing a lot of development on. But I'm going to focus a little bit on the contribution use case. So here you can see a couple of types of backpack we use. The one on the left there is a Mobile Viewpoint Airlink type box. That's got 4 SIM cards in. It can bond over several networks to provide a good data connection, and there's a compression codec in there that compresses the video down, sends it over the network. And similarly with the live view devices, you can see there on the right. And we've got a lot of these. We use them day in and day out, and they're really good for sort of getting to not having to send satellite trucks and not having to send specialist facilities and stuff like that. The problem with them comes, this is a picture from the King's coronation last year. The problem with them comes that you're quite often on a large news event, you're in a scenario like this where you're fighting for space with the general public. Everyone's trying to connect and stream video over the public networks, and very quickly they get saturated and we lose signals, and I'll come back to our solution on that. And in the production example, we've also got a load of other connectivities that we need to add on there as well. So it's not just sending program audio and video. Quite often we'll need a tally light, which is a light on the camera that tells the operator or the person in front of the camera that the camera's on. Camera control units, that's basically controlling the exposure of the camera. We need intercom to be able to speak to the operators. Quite often we'll need return video control signals, teleprompters, camera lighting, fold back, maybe even these days AR and VR tracking. So there's about 11 or 12 different signals that we might want to send bi-directionally over a network. And traditionally, we send the program and audio video over a radio network, and then we have separate radio facilities for a lot of the return paths, which you can imagine can be quite difficult to sort of control a lot of those radio frequencies. So in an IP-based solution where we've got bi-directional video is quite attractive to us. Let's talk a little bit about 5G and the architectures, just to sort of demystify some of the stuff that's going around. So obviously we've got a lot of legacy stuff, which is the 4G LTE stuff. That has worked really well for us for about the past 5 years. We first started doing this kind of thing back in 2012, where we did some stuff with 3G for the Olympic torch relay, and I know Paris 2024 are taking that quite a way forward using 5G networks and stuff like that. So that idea that you can be out there following something round without having to have a satellite truck has been really useful to us. And then 5G's come along. And if you look on the right-hand side here, you can see the sort of vision for 5G, which is this kind of dedicated 5G RAN with a 5G core, radio access network with a 5G core, and everything is giving you very, very high bandwidth. But the problem we've got today is that we've got a lot of these kind of hybrid, or what they call non-standalone networks, which actually rely on the 4G network quite often to provide uplink. So the downlink, when you look at your phone and it says it's 5G, it probably means it's getting a downlink signal on that, but it might be doing uplink via a 4G and LTE. So we don't see that many advantages on the public networks at this point, and that's a little bit of a problem for us when all of our traffic is uplink directional. And then we've got all of these other sort of technologies that are sort of coming in with different sort of network configurations that are available to us from various service providers. So on the left, you've got the best efforts network. That's what we've primarily used up till now. But we don't have any control over that. As I say, it quite often gets very saturated. And then we've got all of these kind of quality of service enablers that come along. So we've got things like traffic prioritization, we've got network slicing, and we've got the snappily named public network integrated non-public network. And that's the idea that you might be in a venue or a stadium or something like that, and you've got a public network there, but you take some of those resources for a non-public network. And then finally, we've got the standalone non-public network. And all of these sort of give us some advantages and disadvantages. So on the best efforts network and everything over to the left, there's no quality of service on it. We can't control the network. We've got no visibility really of it at all. But over in the on the right hand side, you can see we've got lots of quality of service. The best effort stuff is really good for ad hoc, going out with a camera for news and stuff like that. But you really need to plan what you're doing when you're using a standalone non-public network. And they tend to be sort of area restricted as well. So the best effort network, we can virtually use anywhere in the world now. But the dedicated standalone non-public networks are really local area only. And then the other challenge we've got is that a lot of these services in the middle aren't yet commercially available. So we've done a lot of work really focusing on the standalone non-public network, and we've learned a lot of that. And the reason we're able to do that is because there is spectrum available. So this is a kind of global map of spectrum that's available in 5G. A lot of people just speak about 5G as just one thing, but in reality, there's a lot of different spectrum that different territories have made available for it. So the millimeter wave stuff that you'll have heard about, really good for high bandwidth connectivity, not as resilient, and is really only available widely in parts of the US and certain parts of the Far East. In Europe, we're a little bit more restricted on what's available to us in those bands. And then as we get down here, most of the public mobile networks are operating in sort of this space. And then there's some other networks that are operating in the sort of sub 700 megahertz space. That's a problem for us in Europe because we also use that for DTD, digital terrestrial transmission. Our existing radio microphones and things like that all sit in that spectrum under sub 600 megahertz. So it's a little bit of a challenge for us in that space. But primarily in the UK, there's a band that's been made available called N77, which is 3.8, 4.2 megahertz, where we can get some spectrum available for shared access use, which isn't widely available to the mobile network operators. So in the UK, Ofcom basically keep that available for small scale tests and trials and shared access and specialist jobs. And we've also been doing some work down in the N40 band down here, which gives us really good distance, but slightly less bandwidth than we get in the N77 space. But I'll come back to that in a little bit later on. The other thing that you can do as well as with spectrum is use a thing called time division duplex. So TDD is basically the way these networks that work is that traditionally they were frequency duplex. So you had two frequencies, one for send, one receive. In TDD, you've got time slots, and basically you can set time slots for either uplink or downlink. And traditionally, because most of the demand on mobile networks is downlink, they quite often the public networks are tuned to sort of give you a downlink capacity of sort of 3 to 1, or even sort of 7 to 2, which means that for every gigabit of network available, you've got 700 meg for downlink, and then 200 meg for uplink. We can do in this band, because we're slightly separated from the mobile networks, is that we can actually tune this the other way around, so that we can start to give ourselves a lot better, higher uplink. And you can only do that if you're operating in spectrum that's a little bit away from the public, so you need a little bit of a guard band in that. And also by adjusting the time slots and changing the subcarriers, you can get down to some very low latency services as well. So obviously you have to wait for a transmission and a receive to happen, and if you time them right, you can drive the latency down. And what that means is that we can tune them. And what we've done in a lot of this work is that we've tuned to this kind of 2 to 7 uplink versus downlink. That means that here, if you look at these kind of speed tests, we work quite often with a company called Neutral Wireless, who are based in Scotland, who spin out from University of Strathclyde, who do a lot of work in software-defined radio. So you'll see a lot of their branding through these slides. But you can start to see here that we're getting uplink capabilities of, downlink capabilities of 300 meg, uplink of near enough 400 meg, and we get quite good downlink and ping times. And if you start to operate in multiple in, multiple out, rather than single in, single out UEs, you can really start to get the network to really perform. So let's just talk a little bit about this concept of standalone non-public networks. So the idea of this is that basically you've got complete control of the core. So as I said earlier, the public network integrated may be that the core is shared with a mobile network operator, but you might have RAN or control sharing that's giving you sort of private space on that network where nobody else is using it. whereas within a standalone MPN, your network is completely your own. And that basically means you've got complete control of it. So for us, where we're in a self-contained environment, we can spin up a network, we can operate on it, and then we can spin it down, and nobody else can use it. Importantly, you can't just roam from a public network to a private network. You have to have separate SIMs in there. You can connect that network to the outside world, so you can connect that either to the internet or you can connect it to sort of local breakout or whatever. That's optional depending on your workflow. And this is what I'm talking about when I talk about so here you can see we've got a radio head in a box, and we've got an Intel i9 PC up here. That's really the core. And then we've got a radio amplifier, and then on top of that we'll have antennas. And so this box is incredibly portable. We can take it to places, we can deploy it, we can attach several antennas to it, we can attach several radio heads, and we can run quite long fiber runs off the back of that in order to sort of design the network as we want to use it. So I'm going to talk a little bit about how we use the network on the coronation, and then I'll also talk about an event that I did earlier this month out in Northern Ireland, where we were doing some work on a wide area sport event. So this was our sort of basic concept. Effectively, we'd have on the Mall in London, we'd have multiple cameras. We would set up a network that we would then bring in by our broadcast contribution network, which is basically a set of fibers that we have at strategic places around the country where we can bring stuff in. We bring that into our master control room, which is basically then sent into the internet, and that enables us to then route those video signals to wherever we want, or even out to third-party galleries as well. And the beauty of this is that nothing changes from the operational point of view. So the camera crews are all using the existing kit that that they know and they're familiar with. They don't specialist training, and in the MCR and the galleries, everything is just presented the same way as they would be if they were using the mobile viewpoint or live type devices. But we wanted to be sure it worked, so we got together with a lot of broadcasters from across the world. Really, we had Americans, we had Australians, we had a lot of Europeans working on this, and we got together on a very wet day in March last year and did a lot of testing where we just basically set up a cell, connected multiple devices to it to see that we could get the throughput that we wanted, and we did a lot of range testing. And then from that, we looked at the Mall. So the Mall is about 1 kilometre long, and we knew this was going to be the main focus of our event. And for a large royal event in the UK, we have a sort of broadcast compound down here, and then traditionally we would fibre out to camera positions all the way along the Mall. So we knew we had fibre and power at various points along the Mall. So we kind of looked at the best way to do that, and because of the spectrum that we had available, which is, well, we started out with 100 megahertz, it got knocked down to 80 megahertz. We decided that we were going to do an AB pattern up the Mall. So we basically put 4 antennas in, one on a mast covering the area right in front of Buckingham Palace. We had another one about halfway up, and basically we had 40 megahertz of spectrum pointing one way, 40 megahertz going the other way. And then we were able to sort of light up the whole of the Mall, especially dedicated for these cameras. And then we used a tool called Cloud RF, which just enabled us to do some modelling and some LiDAR modelling to sort of indicate where we could get good coverage, and that we were happy with the positioning of the stuff that we were going to have for the coronation. You can see here the types of antennas. So this is one of the camera platforms, or it's actually a radio platform, radio commentary platform here, where we had an antenna here, and then the radio head, and literally we just fibre and took some local power to power the radio head, and we did all this in N77. Down at Canada Gate, we had a trailer mast, so we spanned that up, and actually at Canada Gate we ran 2 networks, and I'll come back to that in a bit. everyone loves the rigging photos, so there's some pictures of us putting the antennas in place. And then we had a porta cabin, and in the porta cabin, that's where we put the core, and we had a whole bunch of control signals here. And you can see here we've got our control. So what's really nice about this is that we're able to sort of see each individual SIM that's on the network, so we could see every single camera that was out there. We can see the throughput it's getting. We can see the yellow ones telling us when they're on air, when they're transmitting. We're even able to monitor the pictures as they're coming off the devices themselves. And so we had quite a lot of control and capabilities, and that was really useful to us, because if somebody was saying actually they can't get a signal, we were able to just kind of say to them, hey, if you move a little bit to the left or the right, you'll be able to sort of get a slightly stronger signal, which you don't get from the mobile network operators. This is our spec thing, and then we also did some testing to see how good the planning was against the predictions, and you can see the network performed really well. I'm just going to play a video now. And the video is actually a comparison between the Queen's funeral and the King's coronation from CBS, our colleagues at CBS. So the first bit, it will break up, and it's bad. This is actually signal that they had coming over the public networks, and then you'll see what happens when they switch to our network for the coronation. So don't adjust your sets. You can see the pictures are breaking up. You'll hear the sound break up in a bit. There we go. So this is kind of quite unusable, and then this is the signal that we saw from the public networks with just two SIMs. We put two SIMs in just to make sure that we could see have some resilience. And how did the network perform? Well, you can see here we've got multiple devices on the network. You can see the public networks were getting kilobits of data through, whereas on the 5G networks, we were able to sort of send easily 10 megabits per second, and give you for HD video, we need about 7 or 8 megabits. Some different broadcasters use different techniques. And we connected a whole bunch of devices. So we had Wi-Fi's that were connected for radio. We had these this is a Hey Vision unit, similar to the live view and the mobile viewpoint. We had a lot of live views on there. We had some other, this is a Netgear stuff. This device here is NEP have basically developed their own sort of specialist box, and we had 75 connected SIMs on there. And as I said earlier, we were able to really sort of monitor the performance of the network, the performance of the cameras, and stuff like that. And then secondly, we decided to run, working with Sony, a low latency network up in the Canada Gate area. This was a kind of R&D piece here. So we were just trying to look at what the production workflows look like. So again, we wanted the low latency. If you look at this video on the right, this is actually sending the video, going into the network, and then coming back. So this is a return feed in that top monitor there, and we're getting quite low latency in there. And if you want to understand more about that, then there's an IBC paper and an AB paper, both available with a lot of the technical details in there. I've got about 2 minutes left, so I'm just going to talk quickly about what we did at the beginning of the month, which is a motorcycle race that happens in Northern Ireland called the Northwest 200. It happens on roads around the north coast of Northern Ireland, which is a very unconnected area. For 51 weeks of the year, it's just sort of farmers and sheep and stuff like that. But actually, for 1 week of the year, there's about 100,000 people deploy, and they race motorbikes around the course. And we were tasked with sort of trying to get these pictures back. So for this one, we deployed 3 networks. Again, at camera positions, none of these were moving. These were all fixed cameras, and we used some specialist sort of wave share devices to connect to the network, and then we plugged in various encoders into those. We've got a high gain antenna on there that was firing over about a kilometre and a half. We had some other cameras available to us. Again, we did simulations, and we were able to see on this one we used band 40, which gives us less bandwidth, but as I said earlier, a lot more distance and a lot more resilience. and we had a van this time with a mast on parked to Cromwell, and that was an M40 network as well with 3 cameras on it, and again really good throughput on that, and that went quite well as well. I'm just briefly going to talk about network slicing because everyone sort of says, oh yeah, but why don't you just use network slicing? Network slicing is really good for certain applications, and it'll do really well in where you need this kind of dedicated IoT type stuff. But when we've had conversations with some of the MNOs about this, they need standalone network to support it, so we're only just starting to see those in the UK. It's a very manual process to set it up, although the automation's on the way, and it could provide a backhaul, but we're not seeing the type of bandwidth. We're seeing maybe 5 megabit in a slice, and that's just not really going to serve our capabilities, and they're very expensive. So I think ITN deployed a slice to bring back one video source, 23 cameras, I think, all mixed down into a single video source, and they used that at the coronation, but it was very limited in its capabilities and very expensive because effectively you're paying for mobile network operator resources. So just some final thoughts from me before I hand over. Private networks work really well in these large-scale planned events. There's still a lot of room for working with MNOs and using these other network architectures as they come along. We're always going to use the public networks, but there are certain applications where standalone non-public networks provide us a whole bunch of benefits for both contribution and production. Yeah, I'm sure there'll be loads of questions at the end, but I'm going to hand over, I think, back to Sarah, who's going to take you through some of the other presentations. Hopefully I'm on time as well, Sarah.
You're ahead of time. Thank you, Ian.
Oh,
Thanks very much for your presentation. You're saving us some time for the Q&A at the end. Thanks a lot. Okay, if you'd like to stop sharing your screen, then we can switch gears now to our next speaker, which is Jurgen De Klerck. Our next 2 speakers will give you the perspective from the 5G providers, whereas Ian gave us the perspective from the media companies. In reference to some of the things Ian was presenting when I was looking him up to search for him as a speaker, I found a lot of these cases and research information online. So if you want to do similar searches, you can find more details for sure. Okay, so Jurgen, you are up and the floor is yours, and thank you for joining us.
Thank you very much, Sarah. So I'm Jurgen De Klerck. I'm a business development manager at Proximus for everything that concerns 5G mobile private networks. And when I talk about 5G, it's always interesting to have a small look to the back, because we have seen that previously technologies really changed business models. And we all know the era of the 2G when mobile phones starts. 3G we know from the Blackberries. And when I ask to my colleagues what's the difference between 3G and 4G, they often give me the answer, yeah, it's speed. But when I was talking to a CIO of a financial institution, he basically told me, yeah, Jurgen, 4G is the technology that closed all my bank offices and replaced them by a mobile app. And there we'll see that 5G is a business enabler for new ways of working, new implementations in not only media, but also healthcare, Industry 4.0. So we all know the capabilities of 5G and an enhanced mobile broadband. We know the latency is a big thing, and with 5G we will be able to connect 1 million devices per square kilometer. And I think it's important. Ian is mainly looking into private networks, but that's for planned events. I think network slicing will have big advantages on unplanned events. When I talk to media companies, and I've seen there's some presence here, I already talked with, one of the biggest issues, or why are we looking to 5G as a media company, is news gathering. And I think their network slicing will have a big a big advance in news gathering and news transformations. So planned events, we have all the time, we can do manual setups, but for news gathering, I truly believe that the softwareization of our network and asking capacity on demand will give you, as a media enterprise, a big advantage. Another important highlight that Ian had was the spectrum. While we at Proximus, we believe actually the same thing. We think the spectrum is really important. So with the last spectrum auction in Belgium in July, we obtained a lot of 5G spectrum. We started with 100 megahertz on the highest bandwidth, and we recently added 20 more megahertz. So we will be on 120 megahertz on the highest bandwidths and have a total of spectrum range and more than 300 megahertz, because I truly believe that if you don't have any spectrum, you won't be able to build all the use cases. So, and when we talk about use cases, and I see Ian tested a lot as well, at Proximus, we truly believe that the use cases and the network comes hand in hand. So this actually means we have to co-create. We have to co-create not only with our existing partners, but with our customers, with competitors, to build the best solutions for the needs of the markets. And we've actually built quite a lot of solutions. And at Proximus, we truly believe that 5G goes way further than some slides. So what I'm gonna present you is present you some concrete box in difficult areas. And the first one I'm going to present you is a use case we've done at a football match, at a football game. It was the Super Cup, so it's a use case we've done at Club Brugge, and Club Brugge is the biggest Belgium football team, so it's the biggest stadium. So there we always had a problem of congestion on 4G, on 5G as well. And what we've done here was to reserve a dedicated bandwidth of capacity. And with that bandwidth, we were able to build some new use cases. We've recorded the match on 5G and streamed it directly to the platform of TikTok, because there's a new generation coming up. There's a new way of experiencing media. When I was younger, I had my television, I had my VHS. Well, today we see Generation Z is more using mobile phones, mobile devices, but also other applications. So when I watch a football game, I just go to the football station, I watch the game. But they use other platforms. They use platforms like TikTok, and that's actually what we've done at Club Brugge.
Eleven Sports est une société de création de contenu sport. Et le fan de foot, il consomme aujourd'hui du sport de façon très, très variée. Groupe jeune, groupe plus âgé, une partie linéaire, une partie digitale, réseaux sociaux. Et donc c'est à nous à apporter ce contenu chez tous ces groupes cibles qu'on a en tête. Depuis qu'Eleven a acquis les droits de la Jupiler League, on a essayé de créer un écosystème avec des partenaires existants comme Proximus, Jens, mais aussi avec de nouveaux partenaires comme MediaPro qui au niveau international est quand même un grand player. Donc ces 4 sociétés, Proximus, Jens, MediaPro et Eleven, on essaye vraiment d'innover dans la production télé, mais pas uniquement télé, mais aussi les autres plateformes plus digitales. Et j'en suis sûr que cette production-ci donnera des résultats qui seront vraiment importants pour l'avenir. Aujourd'hui, il y a plusieurs choses qu'on essaye d'intégrer dans cette production. Il y a en effet la partie linéaire, donc on envoie le feed linéaire par la 5G vers le playout, mais à côté de ça, on fait aussi une production spécifique sur TikTok et on emploie aussi la connectivité 5G pour envoyer le feed en streaming vers la plateforme TikTok.
Le test que l'on fait aujourd'hui s'inscrit vraiment dans une volonté de co-création avec le secteur des médias. Et donc, on va tester 2 nouvelles applications en s'appuyant sur le réseau 5G aujourd'hui. Premièrement, on va streamer le match en live sur TikTok au travers du réseau 5G Proximus. Et deuxièmement, on a équipé des caméras avec des cartes SIM 5G qui vont capter l'ambiance, l'atmosphère autour du stade et dans le stade de manière très mobile. Les avantages de la 5G, c'est de pouvoir s'appuyer sur un réseau qui est stable, qui est performant, qui offre de la bande passante, peu de latence, de la stabilité pour pouvoir envoyer ces images en haute définition de manière à ce que tout soit clair pour les spectateurs.
So in order to do these kind of use cases, you need an environment where you can test these use cases. So to be honest, me as a telco or as a business developer on 5G, I was a bit surprised of the number of material that comes with it. I thought it was a lot of less. So we've done some more use cases where we always went first to our labos. So at Howest, we have a 5G labo with dedicated connectivity where enterprises, media enterprises, other enterprises can test their use case before going live, because I receive a lot of questions. Yeah, Jurgen, how much is going to cost? How much do we need to invest up front? Which kind of connectivity do we need? Well, it's important we test these things together. And I'm going to present you another use case we've done with RTBF for Viva for Life. Viva for Life is a charity program, and where they do live broadcasting as well. The pictures you see here is actually a part of the test setup we've done with the engineers of them.
Viva for Life, c'est une campagne caritative organisée par la RTBF en Fédération Wallonie-Bruxelles. Et ça se fait en période de fin d'année, donc ici depuis 11 ans maintenant. L'objectif principal de Viva for Life, c'est de sensibiliser et de collecter des fonds pour lutter contre la pauvreté infantile. Donc cette opération constitue un marathon de 144 heures, durant lequel les 3 animateurs se relaient pour faire un flux radio continu, avec des émissions en direct 24 heures sur 24 pendant 6 jours. Et au niveau technologique, le challenge principal que nous rencontrons, c'est de venir avec un dispositif qui doit s'intégrer au cœur de la ville, rester le plus léger possible et le plus flexible possible. Et ça, toujours pour permettre la création du contenu, toute plateforme.
Nous travaillons avec la RTBF depuis de nombreuses années et nous travaillons ensemble en collaboration sur ce que la 5G peut leur apporter, sur la réflexion de ce que pourrait être un cas d'usage qui répond à leurs préoccupations business, comment ce cas d'usage est ensuite implémenté et comment potentiellement il peut avoir une grande ampleur. Et ceci est tout à fait faisable pour le métier des médias, comme cela peut être pour d'autres métiers, que ce soit dans les services et la santé publique, l'industrie 4.0 ou autres encore.
On a déployé un réseau 5G privé spécifiquement pour la RTBF de manière à ce qu'elle puisse connecter dessus des caméras, des écrans pour pouvoir gérer de manière totalement indépendante par rapport au réseau mobile public les flux vidéo dont elle a besoin pour la captation des images sur cet événement Viva for Life. Les avantages de la technologie 5G sont la haute bande passante, la faible latence, la stabilité, et comme c'est un réseau privé, la RTBF a le contrôle total sur la capacité du réseau pour pouvoir faire transiter tous les flux vidéo dont elle a besoin pour réaliser de manière mobile la captation d'un tel événement.
La 5G, c'est une technologie qui nous permet d'envisager la flexibilité. On veut se libérer du câblage dans certains cas, pour des sources. On a besoin de la garantie de service parce que quand on est en live, forcément, on doit être sûr que le flux soit continu. Nous étudions avec beaucoup d'intérêt en fait le concept de remote production, ce qui veut dire de garder en fait les outils de production, les régies dans nos bâtiments et d'aller chercher grâce à la 5G le contenu proche de nos publics avec nos moyens légers et de les rapatrier simplement pour produire notre contenu.
Nous proposons à un client une gestion de projet bout en bout, de la définition du cas d'usage jusqu'à l'implémentation du projet et la maîtrise de ce projet, et ensuite la réflexion autour de comment ce projet pourrait avoir une plus grande échelle. Ce qui aussi peut générer chez le client des réflexions autour de besoins d'infrastructure, de besoins de sécurité, de besoins de stockage, qui pourraient être liés à ces cas d'usage. Et chez Proximus Next, nous pouvons accompagner le client dans cette réflexion.
Proximus Next. Tech, biz, people.
So more this year, we also gonna start with Wallycast. Wallycast is it's a project from Proximus Media House, where we're gonna deploy more mobile private networks, more in the Walloon region, where we're gonna do the full remote production and operation. So another thing I hear a lot is capacity. So Jurgen, we need capacity. We don't want any saturation. And therefore, we recently developed event reservation, because we believe there's more than the big media companies to serve. We also believe in the smaller events. And we see that a lot of enterprises today suffer with cashless payments, access control scanners, communication on the field. And therefore, we are capable today to reserve a part of the 4G network as well. So you can call it a pre-slicing solution, where we use private SIMs on public infrastructure, thanks to a multi-operator core network, where we actually have a private core running next to our public core. So we are able to reserve 25% of the public network capacity on 4G. So we started small. We started for an enterprise event at Atlas Copco, and then we did Night of the Proms in Coxeida. After that, we've did bigger events, and this summer we're gonna do I'm not going to tell the names yet, but we're going to do the biggest events with this solution, where we reserve on a dynamic way 25% of the network capacity. The biggest benefits they have is there is no more need for physical infrastructure. There is no need to put local antennas. We create extra space. And as sustainability is an important KPI of many of our enterprises, we reduce the power consumption as well. So, Sarah, that's basically it for me today. I hope I stayed within the time.
Yes. You are all making my job easy. You're all ahead of time so far. Thank you, Jurgen, for your perspective. Much appreciated. If you could also stop sharing your screen, and then we will hand over to Jens from Citymesh. As I said in the beginning, I think that Jens Buysse and Citymesh are part of the steering group of our Media XR and 5G project. Some of the cases you've seen and these situations you've heard about are things that we're trying to tackle and test and experiment with in our project. And we still have room for more members of the steering group for more use cases. So if anything in these presentations is inspiring you to get in touch with us, please do. And we can see if we can help look for some ways to test things that your companies are busy with. So thank you. And Jens, the floor is yours.
Great, thank you. So hopefully I'm sharing my screen now.
Yes. We see it's loading. Yeah, it's ready.
Okay. So hello, everybody. I'm Jens Buysse. I'm the research manager at Citymesh here. So that means I'm concerned with everything which has something to do with either research or with subsidies or grant projects. That's part of my portfolio. We believe that connectivity here at Citymesh is very important. We believe that connectivity shapes the future. We started already communicating with each other by light, using light towers or by light beacons. And that was already a good step forward in ways of communicating with each other from a distance. But of course, we can extend it a little bit towards our current networks, such as Wi-Fi, 4G, 5G, and so forth. So for the people who don't know who Citymesh is, maybe a small history. We started in 2006 as a small company providing Wi-Fi connectivity towards cities and camping grounds. So we saw the city already as a very good playground to make it a smart city. And then a couple of years later, we did some expansion and diversification by also building a 4G network offshore, so for energy islands and for windmill parks. And we also started investigating LTE, private LTE for the event sector, for instance, here for Tomorrowland. Then we saw the big opportunity of smart cities, providing either connectivity using Wi-Fi or connectivity using LTE. And then we became larger and larger, where we started a strategic partnership with Nokia, mainly for our 5G and 4G networks. And then we continued by expanding also towards Sigfox, which is an IoT network, which spans a whole part of Europe and actually a whole part of the world. So at that time, we were both there on the IoT market, on the LTE market, on the private 5G market, on the Wi-Fi market, basically all kinds of connectivity markets. That's where we were in 2021. Then a couple of years ago, we, together with Citymesh, got forces together, and we thought that a fourth telecom operator would be required here in Belgium to lower the prices, because prices here in Belgium are very high for connectivity compared to the other European countries. So we said, well, we need to attack that, and we joined forces together with Digi, which is a Romanian company. They are very proficient in building networks, and now with them we are actually launching the Digi network. I think it will be next year, where we provide services also for the consumer market. So Citymesh focuses on the business market, while Digi together with Citymesh will focus on the B2C market, so the consumer market. And we will position ourselves as a technical powerhouse, as we are not only providing connectivity, but also some services on top of that connectivity. So we offer a couple of solutions. I will not go into too much detail there, because I don't want to stress the time too much. But we are an operator, so we can operate networks. We provide temporary solutions, so temporary networks. I will go into and give an example later on. We're also an integrated solutions. We provide IoT solutions. So we provide, for instance, Sigfox applications on top of the Sigfox network. And we believe that 5G has a big part to play in the mission critical solutions. So whenever your mission and the connectivity required for that mission is critical, so i.e. high bandwidth and low latency, we believe that 5G has a big role to play. And what you also see is there are drone solutions. So we are also a drone operator. So we're able to fly drones BVLOS, which means beyond visual line of sight, using the 5G network we're building out now at the moment. To go into a little more detail, as an example of the safety drone, what you see here is, for instance, a city, and in the middle you see the fire department. Well, on that fire department there is a drone in a box. So and how do you see that? It's actually just a box which is able to open itself and close itself, and where the drone is able to land and take off. Whenever the firefighters or the police departments needs an eye in the sky, or needs some data which they are not able to grasp themselves, they call us. And we have pilots sitting here in Oostkamp, which are able to remotely pilot those drones towards the place where they need to be. For instance, there was a big training event a couple of days ago, where the fire department and the police department required our services. So the pilots here at Oostkamp, they pressed a button, the drone box got open, the drone went up in the air, flew towards the situation which needed to be in focus, and the fire department and the police department had their data and their video as they wanted. So we at Citymesh, we really believe that that drones and 5G go hand in hand. So that's one of the cases we are doing here. So I already told you about IoT solutions. So track and trace solutions, smart metering. Those are things we already are doing. We use the Sigfox network mainly for non-critical situations, as the payload is quite limited. But the range and the way to cross borders, for instance, if you really need that, then Sigfox network is a great solution for your case. So I will tell you some use cases for what we have implemented. Some of our customers, I will go over them and tell what we have implemented. I will focus a little bit more on the 5G or the private 4G for some of these cases. And then I will close off a little bit on the AR VR part where Proof2 Media is focusing on. So, for instance, I mentioned that we also provide temporary networks, so temporary LTE networks. So, for instance, the Graspop Festival and the Doer Festival, they need their own network for cashless payment, as Jurgen already mentioned, but also, for instance, for the communications between the people working there. So you have push-to-video, you have to push-to-talk applications which can run on that. So all kinds of applications can make use of this private network, which you are able to set up very quickly. This does not require days of testing and days of setting up. We are very profound in setting those networks up, and we're really we do that in an instant. What you see on the left-hand side is actually the coverage plot. Red being having a great coverage zone, while if you go to the yellow and the green and the blue, it becomes less. So we see a very centralized coverage plot for the festival. And we do that for a lot of other companies and for a lot of other events and festivals whenever connectivity is required, separate from the public network. Because that's one of the main drivers. You don't want your public network to be saturated if your cashless payment system is on top of it. If your cashless payment setup is not working for 10 minutes, it means that you're not able to get your income for 10 minutes, which can amount to a lot of euros per minute. Another customer of ours is the Port of Zeebrugge, so the Port of Zeebrugge. It's now Port of Antwerp-Bruges, to be more exact. So we have deployed their private 5G network, and they use it for multiple use cases. So they have their safety drone there, which uses the network from there. From Zeebrugge to do inspections and emergencies. They have parameter detection. They have air quality measurement sensors. So they have QNAC sensors deployed over the port to investigate whether the exhaust from the boats or from the ships going in and going out of the harbor meet the standards, for instance. So that's one of the things they were trying to investigate. They have a digital twin consolidating all that sensor data. They also have a connected port enterprise, and they have fixed wireless access for the parts where that was required. So that was one of our first customers and one of the big customers we have. A second big customer of ours is Brussels Airport. They have a full 5G non-standalone network exploited by the Brussels Airport together with us for Citymesh. So again, what are the use cases? Is priority communications. So a good thing of 5G is that you're able to provide priority from one customer of the network towards another customer of the network. So that's what we have implemented using push-to-video and push-to-talk. So also the first responders have connectivity there. We have track and trace and scanning devices which run on top of the network. We have mobile cameras making inspections of the video of the airplanes. There are sensors placed all over the airport which measure all different kinds of things. And you have below the wing operations, so people are able to call each other and work together. So that network is a very big network, and is also one of the big customers of Citymesh, which we are very proud of to be part of. A couple of years ago, we also co-invested together with Takeda, and Takeda is a company situated in Wallonia, which focuses on medical services. And that's actually one of the first warehouses where there's 5G connectivity inside, and where you have autonomous AGVs working together and doing so AGV is an automated guided vehicle, which brings parcels from their place to the other place. So we have deployed our NovaNode. Our NovaNode is our UE, which is called in user equipment. We've deployed that on these AGVs, and now these AGVs can make use of that connectivity to move autonomously within that warehouse. So that's one of the first cases, I think, in Europe or even around the world where that's actually being implemented in that way. So we're very proud of that part. Another big customer is the BASF Antwerpen, where we have developed a complete 5G network, a 5G pilot network, have a full site coverage, and have multiple critical applications on top of it. So we have smart security systems, we have IoT sensors, we have container tracking, communications, so push to video, push to talk. We have a digital twin monitoring all the required services on BASF. So that's also very, very interesting. One of the use cases here is having the firefighters or the people who are responsible for doing the first line of attack whenever an incident happens. They have a live monitor on top of them, so their vitals are being measured. They have a mobile phone which is able to communicate over the 5G network, and all of these sensors are placed on top of the body of the fireman or whatever, so we can see whether the person has fallen down or not, or if an intervention is required or not, or if something's wrong with their vitals. We can measure that, and we put that into a system which can be monitored then centrally. And in every case, there's an emergency there. So that's a very nice, beautiful case of BASF. Secondly, they have problems with foam detection. So they have large basins with chemicals, and whenever foam arises in those basins, that means that something wrong is happening, or there's something in the procedure, and that needs to be detected quite early. They used to do that by manually or on eyesight checking the basins. So what we've done now is put cameras there together with the Nova node, which is on the 5G network. The data is constantly being streamed and being analyzed. And whenever the least amount of foam has been detected, an intervention can be done to intervene there. So that's also a very nice way of working. So we have also done some piloting in the media sector, where we were very interested in multicasting, broadcasting over 5G. So just to explain very shortly what the difference is between unicasting, broadcasting, and multicasting. When you talk about unicasting, it means that you're doing a point-to-point control. So whenever point-to-point connections, you have one person sending, you have one person receiving, and if that's bidirectional, it's actually using resources in both ways. I heard Proximus telling about, for instance, broadcasting or sending out video towards multiple people. If you would do that using unicast, it means that you're actually able to saturate the network with all the same amounts of data. So that could be the case. So in order to alleviate that, you could implement multicast, where multiple subscribers are subscribed to a part of the spectrum which has the data which is sent out for everybody. It could be, for instance, a video stream in a smart stadium being filmed by one of the people on the ground. And as that data is the same for every person receiving it, it doesn't make sense to copy that part of the data in your frequency domain. So what we're doing is actually implementing multicasting or broadcasting to all people efficiently by using the resources as efficient as possible, sending only one data packet to all people who are interested in it. For that, we have implemented or tried the LiveG project, and we have validated that in a hockey stadium context. So what you see here is actually the women's hockey team. We did that together with G. What you see here is multiple UEs are being set up. So UEs in that sense is the cameras, together with the Nova nodes, which are our user equipment being able to connect to the private 5G network. And in the beginning, he was talking about broadcasting part of the network, the distribution and the contributing part of the network. So we also divided that. So part of the network is being used for the contribution, as you can see here. So multiple cameras making videos of the people in the hockey. What you see here, so the multiple people having their camera there, that's actually multicasting. So that part of the network is actually being used primarily to send out the data, and those two UEs, so those two phones you were seeing, receive the same data packet which they were sending. We also used the virtual player there. That was my son also looking at the video. And that was a very successful implementation of 5G broadcast and multicasting. What we found there is that although technology standards are ready and everything is in place, that vendors in that sense still need to make an improvement to make that commercially available on the market. And it's mainly the chipset manufacturers who need to invest in order to obtain that. I'm going to talk a little bit about augmented reality and virtual reality in industry. So a lot of slideware, if I may say so, have AR and VR connected with 5G in a kind of a framework where they, for instance, use AR to do remote assistance for very difficult jobs, which is only a very highly skilled person is able to execute. So you could use a visual assistant, remote monitoring, data visualization. You could use a document navigator, digital workflow. But what I do see is that the UE, so the user equipment, so in this case, the VR goggles and the AR goggles, they're mainly not supporting 5G at the moment. So what you see here is an index or a listing of possible devices, which are AR or VR devices. But what you can see here is that they never support natively 5G. We only found one, which is the DPVR, which is situated in the United States, which should support 5G, but you're not able to buy it because they're out of stock, and we haven't been able to test it there. And all the rest of the more commercially available AR VR goggles, they either use tethering, meaning that you need to have your phone in your pocket, and then either using USB tethering, so with wire, or with Wi-Fi tethering, you're able to connect. So, and then I don't see the added benefit anymore of having a 5G network because you're still using the Wi-Fi network or the USB network to connect your phone. So I do believe, and that's actually the end of my presentation, that the 5G network-wise, everything is ready, but there should be a very large increase or a very high step that needs to be made by the commercial providers of user equipment. And once that is there, I do believe that 5G will be a big enabler, both industry as in media, to do automation, to have AI and machine learning implemented, to do good robotics. So I do believe that the push from that kind of industry is required for us to move even faster than we are doing now. And lastly, here I wanted to talk about the smart wearables. That's also something which is coming up and about. We are talking with a lot of hospitals regarding 5G, but when we ask for them about the smart wearables, they still have the wearables, they are in place, but they still make either a communication to a Wi-Fi hub or to another hub using Bluetooth, and then the data is being sent. So again, the manufacturers and the vendors need to invest in making all these devices 5G natively ready. So I think that was a little bit my presentation. I hope I stayed in time. If you have any questions, you're more than free to ask them either offline or online, or mail me. So thank you for your attention.
Thank you very much, Jens. Much appreciated. I don't see many questions in the Q&A, but that is okay. We have been talking to many companies and have a lot of questions from them already. Maybe Jurgen and Jens, you can all turn on your cameras because some of the questions I have will be for some of you and some for all of you. Ian, I'm going to begin with you as our media representative here because for this project, we've talked to media companies and especially event companies. And the question constantly comes up about 5G cableless cameras. And I wonder what the implementation or existence of those is like currently and how you see that evolving. You have to turn your microphone on. Thank you.
Sorry. So there's a couple of reasons why they both work and don't work. So if you need mobility in the camera, then that's a good reason to sort of lose the cable, or if you've got long distances. So the motorbike race example that I showed you, it's impossible to sort of cable that. So we're able to put cables in and have live cameras where previously we'd only been able to have them for the recorded event. I think there's a few myths around taking all your cameras wireless. So inherently, if you've got a large camera with a large lens on it, that's going to need some sort of power source, and you're in a stadium, then quite a lot of that stuff is quite often pre-wired, and therefore, you know, a wired connection is always going to be more reliable and give you better bandwidth than a mobile connection. So the advantage to having those, but there are certain wide area events, like I said, the motorbike race I did, skiing, marathons, boat races, or the editorial advantage of having things like Steadicams, as I mentioned, means that actually wireless cameras have a lot of capability in that area. And one of the things is we already use a lot of wireless cameras. It's not a new use case for us. You know, we've had wireless cameras for, well, I think the earliest picture I've got of a wireless camera goes back to the 1950s. They've moved from analog to digital and now into IP. So kind of moving into that IP space. The ability to be able to deploy in our own spectrum is quite interesting to us. So we quite often use spectrum in the 2 gig to sort of 2 to 3 gig range. We've got quite a lot of that, and in 10 megahertz channels with an IP-based camera using TDD, we can maybe, instead of deploy 1 camera, we can deploy 3, maybe 4 if you segment, use MIMO and things like that. That means you can start to sort of be more efficient in the use of your spectrum that you've got for those wireless cameras, and that means you know, so again, on the motorbike we had some flip-flop cameras and stuff like that, but things like onboard worn cameras and stuff like that, you know, the more angles you can get, the better, really.
Okay, thank you. The next question that we have heard a lot, and I think this is more for Jurgen and Jens, but Ian, please, if you want to contribute, feel free. Again, in talking to a lot of media and event companies, there is this sort of resistance to discuss XR, which is where our expertise comes in, because they say we can't work with our apps for our fan and user experiences. We can't add nice AR experiences because 5G is not working. The minute we have more than 4,000 people in our music event or at our sport event or at our fun park, then nothing is working, nor Wi-Fi, nor 4G, nor 5G. And so this has been a kind of resistance for us in talking to companies. There's sort of a wall put up immediately, like we're too soon, not ready, not sure what to test. So I just wonder if any of you have any views on that. Yes?
Yeah. Well,
Yeah,
I'll go first then. It's a bit, the network we're building, you have to be aware we're changing our whole network. So Ian was talking about 5G SA and NSA. So therefore we have to really rebuild everything. The network in Europe is mainly Huawei. So we've changed to an Ericsson core already, but we still have to replace oral antennas. So we have to replace about 4,500 antennas from Huawei to Nokia. We're in half now, so we're at 50%. So there's still a lot of work need to be done that we need to do. So the next coming years, the next 2-3 years, we still know what to do. But on the other hand side, we are developing a new product. So I was talking about softwarization of our network, and that will give us the ability to do app-based slicing. So imagine if you're in a football stadium and you want, by any example, you have the app of the football stadium. You always want that to work in the stadium. Works. Why? Because you top up your cashless card, you top up the money for the beer and hamburgers. So we will be able to, the moment you open that app, that comes on a different slice than the other applications. So it's something we are building today. It's not ready yet. It won't be ready this year neither. But in order, the moment it's ready, you want those applications, XR applications, you want them to be ready as well. If you start then, you'll be too late. So in order to be ready on time, it's better to start now than tomorrow.
Okay, thank you. Jens, did you want to add something to that? Or
I just didn't understand the question that well. Are people saying that the 5G network is not sufficient capacity for XR? Is that what's being raised up as a... So there, I think that the answer is twofold. You cannot compare apples with pears. So you either have a public network or you have your private network. If you have your public network, then it's really difficult to have, and you attach your XR application towards that, it's very difficult to have any control over your network because, well, it's part of the public network, and the public network is, as I mentioned, to serve as much people as possible, and not always giving priority to, for instance, an XR application at the moment. Once you have a private network, then secondly, I don't think that your upload or your download will be a problem, as your network is completely reserved for the application in mind. So you have your own frequency band, you have your own frequency part. Nobody else is allowed to go on that. So even then, you can, for instance, optimize your network to give priority to the XR applications. You can also do slicing, as Jurgen mentioned, but then in your private network. So I don't see if you have a private network that XR becomes a problem. It's just one of the other applications, of one of the few applications you will put on your network. So
I think the frustration comes from it being too soon, too fast, too soon, because we're not ready. The 5G networks don't exist just readily available because it's a business to business thing, as you've all said, for the moment. I think that's the frustration. It makes it hard to go that extra step and even look into adding AR to existing apps, because the apps aren't working after 4,000 people are in the fun park, for example, because the 5G network isn't there. I just think for us as a project, trying to figure out with companies what we should look at, what we should experiment, gets complex because, we're not supporting the 5G networks readily at the moment. So let me switch gears and ask a question to all of you. It will probably be our last question because we're almost out of time. We have this project, which we have the chance to experiment a lot with. We are an education institute, as is AP. You guys are in research and development. How can we use projects like this, education, like we give a lot of technical education, to move this 5G and XR discussion along in a good way? It's a very open question, but I'd just be curious for each of you to give some view on that, and then we will wrap up. Jens, I see one on the screen, so I'll start
that, and it's a little bit answering the previous question as well, which is two things. One is, working in production, we tend to do things, learn from it, move on, and they're very short, quick sprints. And I think, as Jurgen says, that gives us the opportunity to sort of test something on a very small scale, deploy it, and sort of do both the lab sort of verification and validate that stuff out in the real world and move on. That's not the case if you're doing large scale networks or large scale distribution projects. So yeah, we've been looking at 5G for distribution. That's a multi-year project rather than a multi-month project, because we need the updates to do that. I think the other thing is look at where you do your rendering. So if you render everything on the device, you've got to ship a lot of data to that device, whereas things like server-side rendering, edge compute may enable you to actually reduce the bandwidth of content that you're sending over the network, or just send the objects that you want rather than a complete rendered experience that actually, so these technologies that are starting to come in that enable us to deliver objects rather than complete experiences, I think are really, and we're doing a lot of work in that in the BBC, and then looking really very much about where those things are composited. So if you've got, you can send the same content to a large scale TV that has no render capability at all, or to a very very clever phone that has a lot of rendering capabilities and stuff like that, and deciding where you do that render, I think, can then help you decide how those different experiences meet on multiple devices over different types of networks. And I think that's probably going to be the key that unlocks it, because then you can reduce your bandwidth. You don't need to send a 4K UHD video image in order just to put some graphics on the screen. You can just send a text file and instruct the device how to display it.
Okay, thank you, Ian. Jens, would you like to add something, or Jurgen? Last words?
Yeah, so you mentioned whether education how education could help binding XR, VR, and 5G together. So one of my callings towards university colleges and colleges is to invest in the education also of RAN and 5G engineers. What we see a lot is if people come here and they want a job here, their experience with 5G or even LTE or even with Wi-Fi is very limited. So if university colleges and universities could spend a lot more time in that, I think that would be very beneficial. Secondly, I do believe that the vendors of user equipment should make at least the devices 5G ready, i.e. being able to use to attach to a non-standalone network, for instance, or attach to a standalone network. So that, for instance, technologies like eMBMS, so the technology I was mentioning was for multicasting and broadcasting, could be implemented and could be tested. And thirdly, I do believe that the lab setups, as you have, for instance, together with Proximus, or the lab setup we're building with the University College of Ghent, gives great strides for other companies to just test and try things out, both even on XR, AR, or whatever technology is required with high bandwidth and low latency. So that's a little bit my calling there.
Okay, thank you very much. And Jurgen, I'll give you the last word, and then I'll just close off and we'll be done in a second. Thank you, everybody, for staying a few minutes over time. Jurgen?
I think for the Proeftuin project, it's important you first define the use cases. So the moment, as we in a research as the Proeftuin is a research project now, the moment you define the use cases, who is the end user? Is the end user a consumer? Is it a private customer? Well, we can add temporary public connectivity as well. We can add temporary 5G spectrum. So I think we should always start from the use case, and then, and in addition to what Ian told, then we need to look, is it only network capabilities you need, or do you need kind of edge computing as well? Do you need those resources as well? So when we talk about 5G private networks or public networks in general at Proximus, we see that a 5G network is more than just connectivity. It's the connectivity, but it's also the integration of the cloud services that companies have today. We see it, we're going to install a private network in a hospital very soon. Well, in addition to the private network, we will install a private cloud on-prem as well. So when we talk about 5G, it's a very wide spectrum of solutions we have today that comes into place.
Okay, thank you very much, Ian. Thank you very much, Jens. Thank you very much, Jurgen, and to all of you who attended this webinar. We are working on use cases. If you're interested in them, please do contact us. You'll be getting a follow-up email from us probably on Monday, and with this video and some extra information. So again, a big thank you to our speakers, and have a lovely lunch, or I hope you had a good lunch while watching the webinar, and keep your eye out for the implementation of 5G and maybe 6G down the line. Okay, thanks everybody. Have a lovely day. Goodbye.
Bye.
Bye.